Hello, everyone. It's my great pleasure to introduce Chris Reed from the Lilly company. And he's the director of product cybersecurity. So he's been running in the hamster wheel for a couple of years now, doing a lot of amazing stuff, working on mitigations, security failures, other kind of issues. And he's going to talk about leveraging DevSecOps and how we can actually escape this hamster wheel of never-ending security fail. I'm very interested in hearing what you have to say about it. He also told me that he's fine with an interactive talk. So if you have questions during the talk, feel free to interrupt him, and we'll see how we can take it from there. So please take it away.
Yep. Yeah, so just a little bit more to give you some of my background so you know what types of questions you can ask. So I've been with Lilly, I'm almost at 19 years. I've been in security for most of that. And I've had a number of security roles. I started out more on the IT side. I've built like our security operations center at one point, managed a team doing that. And I've done security architecture. I've even gone over on an assignment to China for 8 months, where I helped deal with some issues we had in our research center there. And most recently, I've taken over as the director of product cybersecurity. Lilly is getting ready to launch software products. We're traditionally a pharmaceutical company with drug products, but we are starting to add software components to that, and I'm going to give you some context for that today. The other thing that is relevant for the talk today is that I'm also one of our third-party assessors. There are probably 6 or 7 of us at Lilly that go out to when we have companies that are high risk enough, we'll actually go visit them on site. And so I've had the privilege of getting to go peek behind the curtains at places like Box and Microsoft. I've even, before they stopped allowing customers to go, I've actually been on site at AWS in Seattle. And so I've gotten to see how lots of different companies approach security, which helps inform how I do my job. So I really enjoy that part of it. And I think I'll be able to represent lots of different perspectives today. So today, what I want to talk through, I want to set some context for you. First of all, talking about digital health, because this will give some context to why what we're going to talk about with security is so important and essential. And then I want to talk about what I call the hamster wheel, which is the pace of development today compared to the past, and why traditional methods of securing software just aren't keeping up, and why we need to be faster. And then I'll try to propose a solution to that, at least the one that the route that we're taking. And so, again, interrupt at any point if you have questions. So first, of course, there we go. What I'd like to do, I can't talk directly about our software products because they're not currently on the market and they're in development. You can go and research, and we've had articles like in the Wall Street Journal and some other locations where our CEO has talked about our products. But I'm going to give you a hypothetical product today, but you can apply all these things to products we may have. And just to help you connect dots, we're a big maker of diabetes products, so you can imagine insulins and other treatments like that. So you can pretty quickly see the jump that you would make from these to the types of software products we'd have. So what I wanted to give you guys to start with is just a scenario of a medical situation. And this one's actually pretty personal to me. My wife, we luckily have 3 beautiful kids now, but I will tell you that wasn't an easy process. My wife has complicated pregnancies. She's had issues in every single one of them. And in fact, to be perfectly honest, we've actually lost babies fairly far along in pregnancy. And so when a woman goes through that, and even the husband, that can be a pretty stressful time. And so you can imagine she's had preeclampsia, which is really high blood pressure, where she's supposed to be on bed rest. She's actually had gestational diabetes, where she's having to check her blood sugar multiple times a day. And the treatment for these, again, monitoring blood glucose, she'd have to take her blood pressure multiple times a day. And she would write those down in a paper log, and then once a day she'd call the doctor's office and relay all that information. And by the way, that she wasn't talking to the doctor, she was talking to someone that just took it down. And then 2 hours later, the doctor would call back. Also, in addition to that, she would have to go in 3 times a week to do what they call fetal stress testing. She would go in and lay in a bed, and they'd put a fetal heart rate monitor on her stomach and watch the heart rate of the baby for about 30 minutes. So 3 times a week, she had to interrupt her day. And by the way, sometimes with little kids. And then she had to go into an office, strap something on for 30 minutes, and then, again, the doctor would review it later in the day and let her know if there are any issues. And then once a week, too, she had to go in and actually talk to the doctor. So she's having to make 4 doctor trips a week. And this is like in the last 10, 12 weeks. So this is multiple months of this. And again, if you've been through a stressful event, this can be quite a stressful thing to go through. So that's kind of the scenario I want you guys to imagine. So how can we use technology to help that? So I've made up a fictitious app that I call Gestation. Yeah, naming's not my forte, sorry. This is completely fictitious, I promise, but it really illustrates the point of what I'm going to talk about. The features of this app is that it's going to integrate and get your heart rate from your Apple Watch and also that you can have a wearable heart rate monitor for a fetal monitor. So literally all day long, you can just strap that thing on and it'll monitor the heart rate of your baby. You can have a blood pressure device on and also a blood glucose meter. That all is digital. And you can also, in the app, track what medication you've taken, because a lot of times for the glucose, you're taking some type of medication. And it's also just pulling data from all those sources and starting to track it over time. And then also in that app, it will give you information, just basic information about things like if you have a question about, hey, I haven't felt the baby kick in like 4 hours. You could look in the app and it would give you some information about that to maybe help you relax. But the real interesting part here is that it's also going to integrate with the electronic healthcare record that sits back at the doctor's office. Question?
This may be great for question.
Sure.
Go ahead if you have a question.
Sorry.
Yep.
The disembodied voice reminded me again. I forget. So you've got an Apple product. You've got HR monitor from XYZ. You've got a BP device, an EBGM device from ABC and DEF.
Yep.
Who's assuming the liability on the reliability, the accuracy, and repeatability of all that equipment, and how do you mitigate those factors out when you collect it digitally?
That is an excellent question. To be perfectly honest, the answer is that's still unclear. But clearly the manufacturer of the software product is going to take a large part of that. But I will talk to that a little bit. This is obviously, because it's being used in medical care, it's going to be highly regulated, and I'll talk to that a little bit. But to be honest with you, this idea of like wearable stuff, telemetry that people are wearing home and it's informing doctor decisions, like this is a new space for the FDA. And you're starting to see lots of products get there. In fact, a lot of consumer products have walked up to the edge but been very careful not to step across, like HealthKit with Apple and some of the other devices. But even those companies, Apple and Google and everyone, are trying to figure out how to cross the line, but they don't want to take on all that liability, so they're trying to walk it right now. It's a great question. So if all that's going on, I think you guys would agree that we could have some pretty good outcomes here. We have no fetal monitor visits, so my wife gets to save multiple hours a week and the stress of dragging her kids to the office to do those visits. We actually get more regular heart rate data, both from her and the baby. Like, it's not just an hour and a half of data point a week. It's now can be up to 24 hours a day. So we have a lot of data to choose from. We have no phone calls for her to call and wait on hold and then read off the log and then hopefully that gets written down right. And then also you can imagine with this data flow that we could actually be more proactive. Like, imagine now the physician doesn't even have to look at it until she comes in for a visit. But if there's values that are out of certain ranges, it can immediately notify the physician to go take a look. And so we can actually react much quicker. Instead of waiting 2 or 3 days to see a problem, it could be resolved possibly within an hour or being addressed within an hour, which is pretty exciting. Okay, so that's our scenario. I'm just going to reach back and, too far. So this is a horrible architecture diagram, but it's the best I could do really quick. This just kind of gives you an idea of all the different major components that are involved in the system. And so on the bottom left, it's all the equipment that the woman would be wearing. So we can see a heart rate monitor. There's even a glucose sensor, the watch, and both of those are communicating with an iPhone. And that's communicating with our cloud service for the application, which is also communicating back here with the integrated healthcare delivery network to their EHR system. And then ultimately, the doctor on an app, on an iPad, or whatever device they typically use, maybe even at home, they can actually pull up the patient's record and get all sorts of information at their fingerprint. And the other thing I want to show here is some of that information is coming from the EHR, but some of it is pulling the real-time data that we're collecting, because we collect way more data than they want to jam into the EHR system. So in some of this, the diagnostic data, they can see the last ultrasound. You can imagine all the rich data that the physician could have at their fingertip here in this situation. So again, so if I think through the major components, we have a mobile medical application that has an iOS app, and we also would support Android, of course, because that's still the majority in the market. There's a cloud component, and just to give you guys a figure as we go on, there's 3 gateway, what we call API services, that different components like the EHR or the mobile app would talk to. And then behind that, we have what we call microservices that actually store the data and allow the gateway to communicate with key functions inside the cloud. And then, of course, there's this app itself would be a component of the EHR, but something that we are responsible for developing. And there's a protocol, if you look it up, called Smart on Fire that's starting to be used to do this interesting interaction where you can interact directly with the EHR, but also interact with third-party sources and kind of integrate it together. Okay, so that's kind of the software scenario that we have. And so the key thing I would emphasize, and I think the question led very well to this, that this is really a health product, not an IT system. And so there's just a different approach that we have to take to this software. This software is now part of the medical treatment. It's not just some software you're going to download, and we're going to be regulated specifically by the FDA as a medical device. And so we're going to have to show very rigorous control of that environment. And if you go out and look up pre-market cybersecurity guidance with the FDA, you will see that they require design including safety hazard analysis, and they require software update capabilities. Why would we ever update software, right? It's always perfect. And then they actually have come out with what they call post-market guidance. So the first one is saying, hey, you need to make sure you've designed security into your product and that you are sure that it can be used in a safe way. The second one talks about once it's on the market, you're not off the hook. You guys have heard, there's a legacy medical device problem out in the market right now. There's a lot of legacy medical devices that aren't well patched. And so even last year, you had things like WannaCry that tore through medical devices in hospital contexts because of that legacy mindset that we never had to patch this piece of medical equipment because it's too sensitive to patch. And so the FDA basically came out and said, no, you will patch. And don't expect to get anything through unless you have a clear plan on how you're going to do that. And then, of course, if we're dealing with patient information in the US, we have HIPAA, which is going to require process and technical controls. And then emerging in Europe, you have GDPR, which actually mandates security by design. So you can't just come in and slap it on at the end. Like, you really have to have shown you made a conscious effort to secure all the information in that product. And then lastly, you have to think about what this looks like in the field, the customer support of it. How are you going to manage when the patient's in control about when they upgrade the app? If you have a major issue, how do you make sure that the patient understands that and upgrades their software? What about, do you guys have anyone that you know that never applies their phone updates? Yeah, people don't do that. I have family members that usually, like, when I see them, they're like, I've been getting an error, and sure enough, I update their software and it's gone. So we have to learn how to operate in this type of environment and maintain the security and, most importantly to the FDA, the safety of this environment. So the question about the liability of this is a big question right now. When something goes wrong, who's at fault? Is it, if the patient didn't upgrade their software, didn't put a strong passcode on their device, is it their fault? Or is it our fault because we didn't require them to do that? And a lot of that will play out in the marketplace as time goes on. Any questions? So this is the context we're kind of working in, just to give you an idea of the sensitivity of it. All right, so then we have the fun of the hamster wheel, okay? So let me describe the hamster wheel. I might step back here because this one's gonna have to build. My clicker isn't working quite as well. So a lot of you have probably seen something like this. It's usually associated with something called agile software development methodology, although to be honest with you, it's really just waterfall driven, drawn in an infinite loop. But what's interesting about this is if you think about software development in the old school way, and honestly, it doesn't matter if it's waterfall or agile, even at a fast pace, you might do 3 releases of software a year, okay? And so I'm going to go through how we handle a cycle that moves at that pace. First thing we're going to do in the planning phase, we're going to do some type of risk assessment to just understand what type of data we're using, what type of safety implications we could have, because this is going to help us dial in like how much work are we going to have to do on the security side. And I put a week there. That's probably generous because, you know, by the time you have meetings and get people together, it probably takes a couple weeks to kind of figure that out. But let's be nice and give it a week to do that. We then, of course, we inventory all the different open source tools we're using during development. And I'm smiling because that is not a practice that you see a lot. Usually developers are just like, oh, this is cool, and they load it into their development. But you need to make sure you're inventorying. You can do what we call static analysis scans to make sure we're, as the developers are getting to certain points in the project, to make sure that they haven't made any major coding mistakes. And again, I'm putting timelines on these. These are days, measured in days, maybe weeks. Then as you're getting to the point where you're actually building, you might run a dynamic scan to actually launch some attacks at the software and see how it reacts. And then when we're really ready, we're going to pay some team to come in and do a pen test. And that's going to, like, the final system, we're ready to put it out the door. Let's see, let's pay someone to come do what they can to it and see what we find. And you'd be lucky if that takes just 2 weeks because, you know, this is very manual work and can be very intense. And then, of course, when you're operating it over in production, you're going to patch the infrastructure, every 30 days or so. And then, of course, you're paying attention to open source, so you're going to be patching all the open source that you have through the whole product. And I put question mark days because I think it depends on what you're patching, how often that would happen, and how long it would take you. And, of course, we're going to vulnerability scan and pen test that production environment on some basis because that's just kind of the current practice of how we handle software environments. So that's kind of the way traditional security tends to work. Would anyone care to add something, or does that sound familiar with anything that you've seen? I know at least a few people in the room know what this typically looks like. I'm seeing a lot of heads shaking yes. So again, this might work. It's already stressful, but it might work at a scale where you're only releasing every 3 or 4 months. And even then, that's actually 10 weeks worth of security work in a process that might take 3 or 4 months. So we're already we're already stressed out because that's a lot of time, and the development team, of course, is never waiting on the security team to do any work. So this is where it gets bad. How many in the room have heard of DevOps? Okay, about half of the room. How many in the room feel like they understand what that looks like in practice? Some. So let me talk through what this looks like a little bit. DevOps is the idea that we're going to automate a lot of things, and that we're going to go through this loop. We're not going to do it in months. We're going to do it in weeks and sometimes in days. There are companies, if you go out and look, like Netflix, where literally they're rolling out to production multiple times a day, and they just let it rip. So all day long, they're rolling changes out. And so this is really a factor of DevOps more than it is agile development. But the idea is that you're making lots of little changes, and so when something breaks, you have a better idea of exactly what just broke it, and you can just roll off. And so the other thing Netflix does that's fun and interesting, have you guys ever heard of a tool called Chaos Monkey? They literally have a tool they run in production that'll go randomly break parts of their software so that they can test how fast they can diagnose and react to it. And they do all that like live just to make sure their environment's resilient. They work at a speed that most software places aren't used to working at. And so they're able to do this with tools because they can use GitHub and keep track of their software, the types of changes they're making. They can know exactly what version of code went when, and they can revert back to code. They can branch the code and be working on multiple types of features at the same time and then carefully merge all that back. There's a common tool that you'll hear of called Jenkins that helps automate a lot of this process. So you can almost think of Jenkins as the orchestrator of when I check the software, it's going to see when I check code into the repository, and then it's automatically going to kick off testing and building. And this process, in order to move that fast, you can't do any step manually. It's all automated. And so Jenkins is kind of the orchestrator that does that. Jira has a fun stack where they can keep track. You can have bugs get sent back to Jira for developers to resolve. It's also where you might keep track of requirements. And basically Jira becomes a place where you can kind of manage your work. And of course, I assume a lot of you have heard of AWS, where literally, it used to be even just servers that you could spin up and down at will, but now you get into this concept of containers, which aren't even full servers. And the idea that, in the old environment, you had servers that would run for years, and it was a big deal when you went to upgrade to a new operating system or something like that. Well, in the new world, it may only be weeks that an environment is up and running, and it may even be less time than that. So you're going to have lots of environments that just don't live very long, and then they're gone, and new environments have taken their place. So this process is going to happen very fast and automated. Okay. So again, the velocity is fast. What's interesting too about the container approach is persistence isn't there. Your database becomes your only data store that's persistent. Like your servers are just gone. There is no, you can't say server X is where that issue happened, because server X is no longer there. It went away 2 weeks ago. So diagnosing problems and things like that, you have to be very quick and have lots of good data to tell what happened where. And then again, the scale of this is just very fast, lots of different pieces. And this is fun in an environment where our compliance burden and the level of security we have to have is only increasing. So we have to be better at security than we've ever been, but yet we have to move fast. In the old school model, basically what happens here is that this is literally footage of my career, trying to keep up. Yeah, that's how it feels if you're a security person, right? And my favorite part is when he falls out and he's just shaking.
And then he starts all over.
He starts all over, yeah, because we got to go to work, right? No, I mean, honestly, it feels like that sometimes. Sometimes the speed people are talking about moving at, we just need to learn to innovate and do things a little differently. And so all is not hopeless. And the big thing I'd say here is if you can't beat them, we've got to join them. We've got to figure out how to work in this environment at the speed that they're working at. So this slide's a little busy, but I'm going to take a few minutes to explain it. What we need to start doing is running our security as code, like as part of the system. We have to automate wherever possible. So let me explain on the top right first. The top right is showing you software branching that's happening inside your source code. So along the bottom, you have what we would call the master branch. The master branch is usually the code that you have running out in production. So it should be very stable by the time it gets there. So if you look down here, you have production. This is that master branch. Then you have a release branch. A release is, hey, I'm working on this set of code, and this is the code that I'm formally testing and planning to release out to production at some point and push back into the master branch. And then what happens is developers will branch off of that to do feature development. And so you can imagine, depending on the speed that folks are moving at, there's usually multiple features being developed all at the same time, and all that's being merged back into the release. And I'm kind of trying to illustrate that there. Multiple check-ins of the code happening. Usually just one developer is working on a feature. But when they check in their code, someone's looking at it, and eventually it's merging back down into here. And basically, you can think of the red dots as development. It kind of looks navy blue or purple. I can't tell on this monitor. That is where we're doing testing, and then ultimately what we're going to run in production. And so what we need to do is in this process, we want to automate all the areas where we have the highest risks. In fact, we'll probably verify the same thing at multiple points in multiple ways through the process because we're going to automate it. So we don't have to, that one scan that we ran dynamically one time in a release, why not run it every time they check in code? Because we can. And so we can start to manage change on a smaller scale. So let me talk through that a little bit. In the development side, we can do things like there's a SCA is software composition analysis. It'll identify the open source software in your tools, and it'll tell you if there's any vulnerabilities in them. So why not, as soon as the developer checks in code, run that. That way, if the developer tries to sneak something in there you weren't aware of, it's going to get flagged and inventoried, and if it's vulnerable, we can actually even stop the developer from checking it in and make them go back and fix it. That way they're not finding out in 3 weeks, they're finding out, oh shoot, I thought I was done, but it didn't pass, and I've got to fix that before I finish checking it in. So you're giving them that feedback right away. SAST is static analysis, security testing. So it's looking at the source code and trying to see, did the developer make any mistakes? Are they doing validation checks? Do they have cross-site scripting? You can run that test. And again, you can run it right when the developer checks in and they're getting immediate feedback. So if they need to fix something, they can do that. And then also you can run what I would call security unit tests. So there may be certain things that you just want to verify right away. An example of this would be if you're writing an API that has authentication, you may have a unit test that just verifies, like let's say it's taking a OAuth token of some type to authenticate. You can have it go ahead and check, hey, is it validating the signature? Can I give it a bad signature, and does it reject it? You can do different types of testing to make sure that the key controls that you need to have in place are actually working all the way back when the developer's checking that in. And again, you can only do it on the unit test, or the unit scale, but you can start running those tests immediately. And those same tests will typically continue to run all the way through this process. As you move into the next level, you can start to pull pieces together and test the system. So you can't really run dynamic tests too easily back in development, but now that we have, like if the system has multiple APIs and services, we can now start to run more complicated tests that require the whole system to be up. And so you might have multiple source code branches that are all coming in and need to be tested for integration. And so there's security checks that you'd want to do to make sure it's all integrating well together. And then, of course, when you move to production, there's other things that you want to keep doing, even in a production environment. And the thing here that I would emphasize is, and this is kind of the point on the second bullet on the left. Like I said, this is a little bit of a busy slide, but you want to verify both on change, and you may also run a schedule where it just runs. So especially here on the integration level, you just may want to go ahead and run all your tests once a week just to make sure you have an eye on what's going on. Because, for example, there may be a third-party library that wasn't vulnerable last week that's now vulnerable. And so you don't want to wait and find that all the way when you're in production. And so sometimes you're going to schedule these tests to run. Sometimes you're going to run it when changes are happening. And the cool thing is, since we're automating it, we're just going to do both. Does that make sense? So one more piece to really give you the idea of why this is complicated in DevOps is you're also going to treat your infrastructure as code. So it's not just software that you're writing. You're going to have, like in Amazon, they have this concept of cloud formation scripts where you basically script the environment you need to have to host your software. And when you're ready to spin up an environment, you give that template to Amazon, and it basically goes and builds your data center that you need. It can be lots of containers, lots of servers, lots of data areas. And so that same infrastructure can also go through a software development process, because it's now essentially software, not just an environment you've waited for people to manually test or manually build. In fact, what's cool about that is if we want to have a test environment, we literally just spin it up and we run it and then we tear it down. So things are very dynamic. The last thing I want to say on this slide is typically when you're back here in development, if we're finding issues, we're just going to open bugs for the developers, because these are just things they need to fix, but it's not really hurting anything yet. As you move into testing, usually, especially in a regulated environment, these are now what we call anomalies, and we're going to have to keep track of those, because at the end of the day, when we go to submit, we need to show like all the different test failures we've had and how we've resolved every single one of those. So when we get into this phase, we have to make sure we're tracking those a little tighter. And then obviously, once it's deployed, you now have more of what I would call an incident. Like if you run some testing and it fails, and you have that environment running in production, you now need to respond because it's live on the internet, and you could have a real problem. So as you go to the right, when you find problems, they kind of escalate in how serious they are. Okay? Any questions? That's a lot, but hopefully the DevOps makes sense. We're moving at very fast speeds and basically trying to automate all of it. This is just another view. So typically, one of those boxes is, or to progress through there, we run what we call pipelines. Has anyone ever heard of that term? A couple people. So a pipeline is basically when I have some event like the source code gets merged in, this is where Jenkins comes in, and Jenkins has a whole set of steps that it's going to walk through in order to get that code moved on to the next phase. So I know this text is way too small for you to read, and I did that on purpose because I don't want you to get caught in the detail. But you can see it's kind of like a flow chart, right? And you can see there's decisions places. So what's happening is you have tools that might get used. So Sneak is a tool that will do software composition analysis. It'll look for third-party libraries and whether or not they're vulnerable. Checkmarks will do static analysis. And so literally your automation can run those tools and then get the results. And the cool part about pipelines is if the results are bad, we can do what we call breaking the build. So, you failed. So this little triangle, or this little, what would that be? This little decision here would be basically a decision point of, hey, did I have too many failures, and do I need to go ahead and fail the build? If it fails, it'll send data like to notify the developers, and it'll maybe send those results into Jira as a bug for someone to go fix. So the other thing that's going on through this process is the way DevOps works is you build software by having a container, and you load your software into that container and basically start running your tests on that container. And the container is basically an abstraction of the host that the software is going to run on. And if it passes through all of its tests, including its unit tests, you're going to check it into a repository that then when you go to QA, you're going to start with that container and start running the next set of tests. So again, the infrastructure has been coded and all the testing has been coded. Acunetics is a tool that you could use to do dynamic scanning. The other thing I would point out here is because we have tests happening all over the place, there's tools like SonarQube that let you grab data from all the different tools and get a dashboard over the overall health of the system. Okay, so I have one more slide, and this one intentionally is trying to freak you out a little bit, so don't worry about the fact that it's a little overwhelming. I'll explain it. If I go back to the example app that I talked through, gestation, this would be an example of all the different pipelines that are happening to make that environment work. So every little red line is a pipeline happening with all sorts of automation. And if I'm working on the core mobile medical app and I check in my code, the pipeline runs and it runs through all of its automated checks. And if I pass, it actually feeds the test environment. And the test environment, since it now has that code, will run through all of its automated checks. And so you can see how we have basically over 50 different pipelines now that as changes are happening in the system, automation is kicking off to kind of check and integrate and automate. And this is how Netflix and companies like that are able to roll the production so fast, is they automate almost everything. And so they're constantly checking everything they're doing every time they make changes. And they're learning quickly when they make mistakes. If they have mistakes make it through production, here's the other cool part about this. If they have mistakes that make it all the way over here, they can go, how do we keep that mistake from happening again? And they can now automate that check back in here. And so this is where I talk about its security as code. Because now we're going to start figuring out how to code all the checks to keep failure from happening at the end of the process. Okay, question?
So let's say, God forbid, something happens in deployment that doesn't work. Hardly happens, I'm sure.
Yeah.
But so you found out what's wrong with the code. But then how do you go back to your pipeline system and say, okay, how did it get through the pipeline?
Yes, it depends. There's a couple, great question. So there's a couple things. First of all, it's where you're recording the change and knowing you need to make the fix. And it really, the answer depends on how it got detected. So for instance, if it's over here in production and it happens to be a vulnerable third-party library, you're gonna see the data and it's gonna say, well, that vulnerability just got released last week and that's why it just happened. But you have to now take action to fix that. And so you have to fix it at the right spot and let it go through all the testing to make sure that upgraded software doesn't break anything in the system. But the cool part is you can now do that and have lots of testing that's automated to be confident that by changing to the latest version of that library, it won't break everything. Because a lot of times that's what makes people nervous. Like, oh, we haven't patched that system in 3 months. If we apply that patch, what's going to happen? But if we do these small changes, you can tweak that. If we find a new change, like if we find an incident because we've had something bad happen and we're manually, like that's now work. So what I would say there is, as a security professional, now my time is spent looking at how the system is running, not like running a scan and writing a report and trying to convince them to, go fix a problem. Like I'm now looking at the overall system and trying to figure out, as I'm finding problems back here, I'm trying to figure out where to go automate that. And I'm also watching the types of errors that the tools are picking up. And, as an example, if they keep seeing cross-site scripting come up, I'm going to see that data on my dashboard, and I'm going to go, wow, I need to go back and reinforce with my developers that I see this mistake happening a lot. I need to go back and try to keep them from making the mistake in the first place. But you can use all the data to do that. The other thing I would emphasize here is all these tools are generating records. And so now when we're asked to do compliance, we have a lot of data, a log trail, an audit trail of all the different things that we've checked and when they've passed. And we can point to that as proof of the continuous testing that we're doing to make sure our product's working as claimed. Okay. Larry? He's trying to unmute.
All right, sorry. So Chris, I think the diagram's awesome for showing the linear nature of those tasks. But what about when you get into test and you have to have integration among all of those different components? How is that automated?
Yeah, that's a great question. My diagram probably fails to show that very well. I probably need to go back and work on it. What I'm trying to show here, when you see like reduced arrows, these are still happening on every service, but this arrow really is these three feeding it. And again, if I make a change, so this is saying in the Bluetooth component of the code, if I make a change here and it makes it through here, it then goes into this, it gets merged into the release, it makes it to here, and then that kicks off integration testing, and then when that goes, it's now going to start to do full integration across the whole system. I probably need to show like little funnels that are going down in there. It's a great question though. So you're always going to start out doing what you can on the unit level, but then it's going to flow together and you're going to have to start doing that integration. Great question. Any other questions? I'm trying to watch my time here. So that all sounds like magic, and it is a little bit, because I'd love to say it's that easy. It's not. So really, if you take this approach, there's three key things that we really need to work on. First is connecting all the dots. I mentioned already, the security person is now standing back to look at the system. There are manual steps in this process still. There are times when you want to slow it down and do things manually. As an example, if one of the developed changes is to introduce a new authentication system, you're probably going to slow down and manually look at that and figure out what tests you need to change and reintegrate into your system. And those are going to be changes where you're manually going to not allow things to flow through the whole system automatically. However, if you do a risk assessment up front on the change and it's low, you're just going to let it fly through the process, and if it passes everything, you're going to push the button and send it to production. You're also going to do something we call threat modeling. You heard me say repeatedly that you're looking for the high-risk security areas. Threat modeling is going to help you identify all those parts of the system that you care about most: authentication, access control. And with that threat modeling, that'll help you identify where you want to integrate automated security testing. And so there is manual work happening. In fact, it's still a lot of work, just to be clear. It's just when you automate it, you can now scale. You can scale your expertise at a level that you might not have been able to do before. And the other thing, I kind of mentioned this already, but if you use this process, it has a lot of telemetry. It's almost self-documenting. You get results in real time. If you integrate it correctly, where bugs are getting sent back to Jira and then developers are being assigned that bug and they're fixing it, you literally can trace, like, here's the test that failed, here's the bug that got created, here's the developer, here's the check-in that fixed the bug, and by the way, and here's the test where it passed. And you can literally trace through the system all the work that's actually happening now. That type of control is ideal to be able to show that we can prove in our system that we're controlling it. And then lastly, I've kind of made this point already, you can iterate fast. And when you learn of problems, you can figure out how to get it back in the system.
Right, nice work. So far, instead of doing a reactive security work that you did before, you have now been deeply integrated. But you may run into the problem of having to triage, yes, right? Because all this telemetry will sum up, right? So you have thousands, tens of thousands of messages, yes, and you run into instead of having the problem to having to react to a single incident, you now have potentially hundreds of incidents just like sitting there and adding red flags on your console. How do you triage?
Yeah. So that's a great question, and in fact, that would bring me to another point that you can't just set all this up and then turn it on and hope it works on day one. There's a lot of processes. Like right now, I'm working on integrating some of these tools into certain processes, and we do like what we call an onboarding process, where we manually fix and reduce the noise, and then not until we get it to where it's passing and not creating noise do we automate it. and especially we don't break the build and cause development to stop until we know that it's in a healthy state. And so it becomes a little bit of how you tool the system, so that you don't just turn, if you just scan with default policies on day one at every point in the process, you're going to have thousands of events and you're going to be overwhelmed with all the noise. So it's kind of like, it's that, how do we add it step by step and slowly, so that we're not overwhelming developers? Because at the end of the day, they're not there just to fix security problems that are found. They're there to get code out. And so this is, you kind of mature into this, and that's probably the point I want to make on the last one, is you iterate and get better. And the cool part is if you do that and you're automating everything, over time, your system, a lot of legacy systems get less secure over time. If you do this right, you'll actually increase the security over time of your system because you keep working back and increasing the level of checks in the system. Saw another question. I know we're, okay.
So on the consumer devices, iOS devices, the Android, how do you test and validate?
Yeah, you got it.
So on the consumer controlled devices, how do you validate? Because these devices are untrusted, right? Lily didn't deploy them.
Yeah.
You don't know how the user may interact with the application. There's certainly a design implementation of how you want them to interact with it, but
Yep.
you can't control the user.
Agreed.
So how do you validate for their inconsistencies? And
Yeah, so we have to design those controls in. So as an example, I hope it's rare now, but there are users that probably still don't put a passcode on their device, right? And
very common.
if you start out with that, you're kind of in trouble from the start, because that means anyone can come up and interact with that device and do things on the system. We have to think through those in the threat modeling process, and then make sure we have controls, and then we that are built in to detect those scenarios, like if there's not a passcode set, and then we have to react appropriately based on
or jailbroken device.
Yeah. So is the device jailbroken? Does it have a passcode? And then basically, depending on the safety of the situation, we may take different approaches. We may just warn the user, hey, you don't have a passcode set. We don't recommend that. But we may still let them use the application. But let's say it's controlling like an automated device that does insulin delivery. In that case, we're going to say, oh, you can't use this app until you remediate this problem. So we absolutely have to operate like that. We also have to protect the app code to make sure people aren't figuring out how to bypass those controls, because you can do all sorts of fun things, especially on Android. So we're having to think through all those situations. And the thing that the FDA is looking for is that we've done as good of a job as we can. There's always risk in these systems. We're never going to eliminate risk, but we need to manage it. Especially we need to manage it to make the device safe to use. But it doesn't mean that things aren't going to happen. In fact, it doesn't mean that, just like with a drug product, there are some people that take a drug or they take too much, and it obviously becomes harmful. And so, but we have to kind of show that the logic of how we've accounted for all that. Yep.
In terms of the automated secure SDLC, right, with static analysis and dynamic analysis, how are you handling that for the mobile apps, right? Because typically, is those are done manually, right? You're code reviewing manually, and
they're
you're
definitely
doing
more
manual.
difficult. We do have static analysis tools, but you're right, the effectiveness of them aren't as good. Again, I'm kind of presenting a simplistic view. When we have major feature releases, we'll still do they're already doing code reviews by peers to get it in. We'll also do audits of code later on down the line. So we're not just relying on that tool. The other thing about the mobile devices, there are ways that we can do a fair amount of automation where we're simulating lots of different hardware models, but a lot of it's simulation. And then we still end up doing some amount of real finger to hardware testing at some point.
So you're testing the APIs that the mobile apps are using, I would
Yep.
assume, right?
Yeah, testing
Automating
the APIs,
that.
but even the mobile, we're definitely testing the APIs, but even the screen presses, there is software where we can automate some of that. When we do a major release, there's going to be a lot more of that manual work involved. If we want to patch something, we're going to let a lot of the automation cover what we need to make sure, we use the term like smoke test. Hey, we've done enough checking to know that we have a pretty high confidence that that library change didn't actually break the way our product worked. So those are the types of decisions we make early on. Good question. I think I'm at time, so any other questions? Okay. I'm happy. I'll be around, and I think there's an event here shortly, so come talk to us. But I'd love to hear more questions and feedback, and hopefully this got your minds thinking about how software development in the cloud and things like that work here, and hopefully you look to this because it's a pretty exciting area that's going to define a lot of our future. So, great. Thanks, everyone.
Thank you.